Good evening, everyone. A warm welcome to Day 5 of the International Faculty Development Program on Futuristic Pathways in Technology and Computational Methodologies. I am Arun Kumar Ganeshan, your host for today. As we continue this enlightening journey, today's focus takes us into the exciting and boundless realm of research in information technology. The topic for today is Future Scope for Research in Information Technology, a subject that holds key to driving innovation, solving complex challenges, and shaping the future of technology as we know it. We are privileged to be joined by a distinguished expert who will guide us through this fascinating domain, sharing insights on emerging trends, groundbreaking advancement, and potential areas of exploration that researchers and technologists can embrace in the coming years. To begin today's proceeding, I invite Ms. Pavitra, Assistant Professor in the Department of Computer Science, to propose the welcome address. Over to you, Ms. Pavitra.
Thank you, sir. Good evening to everyone. Technology is the best when it brings the people together. Keeping this thought in mind, a warm welcome to 5th Day International Faculty Development Program on Futuristic Pathways in Technology and Computational Methodology. Today's session promises to delve into your future scope for your research and information technology. Let me begin by extending our heartfelt gratitude and respect to our beloved principal, Reverend Father Isaac P.J. CMI, whose visionary and leadership has been instrumental in forecasting academic excellence and innovation at our institution. We also warmly welcome our Vice Principal, Reverend Father Josie Parantote CMI, whose constant support and encouragement have been beacon of guidance for all of us. A special and enthusiastic welcome goes to our esteemed chief guest and speaker for the day, Dr. S. Vimala, Professor, Dean Academic, Mother Teresa University, Kodaikanal. Ma'am, we are honored by your presence and eagerly look forward your insights on how technology can lead the way in creating innovative technology in future. I would also like to take this opportunity to acknowledge and welcome the program coordinators who have meticulously planned each session and the faculty members whose participation in this event. A warm welcome to all the participants joining us today, whose enthusiasm and engagement have made this FDP a resounding success so far. As we navigate today's session, let us immerse ourselves in the enlightenment discussion about future information technology that is not just a trend but a necessary for a better tomorrow. Let us learn, question, and innovate together. Thank you. We welcome you, ma'am.
Yeah, a very good evening to one and all. Shall I start the session now?
Yes, ma'am.
Yeah. So, first and foremost, I would like to thank the management and the principal for inviting me as a chief guest, sorry, as the resource person for this international faculty development program. And I also thank the organizing committee led by Ms. Shakti, who has taken tremendous effort to organize this FTP. It is today, in today's scenario, it's very difficult to organize such program, inviting many people to make them join together and conducting this program for 1 week. It's a tough job. And Ms. Shakti and her team done this. I appreciate the team for taking that much efforts to come out with such a program. And I also invite the participants for this technical session on future research, how it can be done in the field of information technology. With that, I'll start the session now. Good evening, one and all, once again. Can I share it? Hello?
Yes, ma'am.
Yes, ma'am.
Is it visible? Is it visible? Hello?
No, ma'am, it's not visible.
It is not visible. I can share entire screen, right?
Yes, ma'am.
Yeah. It's getting shared. Sir, I have selected the entire screen and sharing it, but it's taking time.
No problem, ma'am.
Okay. Or I shall send the PowerPoint file to your mail ID so that you can share from your side, right?
Yes, ma'am.
Yeah. Can you just give your mail ID?
arunkumarganeshan.mca.
Full name I have to type, right? Arun
Yes,
Kumar Ganeshan.
Ganeshan.
Spelling?
ARUN
Yes.
KUMAR
Yes.
GANESH.
SHAN.
Sorry, ma'am. GANESH.
Yeah, that's what. GANESH.
GANESHAN.MCA.
SHAN.
Yes, AN, ma'am, not H.
Okay. SAN
Dot MCA
dot MCA
at gmail.com.
at gmail.com. Yeah, I have sent it, sir.
Okay, ma'am, I'll check.
Yeah, you please share it from your side. Yes, Shanti Sanjay, ma'am, you have raised a hand. Anything to be discussed now? Yeah, I shall start the session. Shall I?
Yes, ma'am.
Yeah. See, we will be seeing how the future is going to be in the field of information technology and what are all the opportunities that are waiting for us to proceed with our research. Next slide. So the major research areas in the field of computer science, in the field of IT, the dominating concept nowadays is the artificial intelligence, which is almost used everywhere, mainly in natural language processing, computer vision, and robotics. So natural language processing, I think all of you might be aware of where and all NLP is used. Suppose if I sit in front of the machine and if I speak in Tamil, it will translate that into English. If I tell something, the correct text will be generated, and that is how the NLP is used nowadays. So we have a lot of scope in NLP. Then computer vision, where the digital image processing plays a major role in computer vision. Actually, the digital image processing, the results that are generated by digital image processing algorithms, so they are categorized into two types. One is the user vision and the human vision and computer vision. In human vision, if we give the input as image, the output will also be an image, but it will be in a different form. So maybe I'll be enhancing it, or I'll be making some enhancements to the images. I'll compress I'll give an input as an image, and that will be compressed. The compressed image will be the result of the image compression algorithms. So these things come under human vision. So that is for the vision of the human. In image processing algorithms, if we give image as input, the output will also be image. So that comes under human vision. But as far as computer vision is concerned, the input will be image, but the output will be something else rather than an image. Maybe the description of an image, the features we will be generating from the images. So that is what the computer vision, where artificial intelligence is the main tool which is used in computer vision, and we will be seeing it later. And if you start doing a research also, you will be realizing how computer vision is helpful in medical image processing, medical image analytics and all. And robotics, everywhere robotics is there, right from harvesting the field, then assembling parts, in manufacturing, in performing household work. So everywhere we are using robotics, and the underlying concept is the artificial intelligence. Now, next comes the data science and analysis. In earlier days, the amount of data what we were processing is very small in volume, but nowadays it has increased in multifold. Every minute, every millisecond, we get large volumes of generated. So let us take the example of Amazon, with which everyone is familiar. Every millisecond, people from all over the world, they are ordering online. And you just think of how much data is generated. A single person will be typing 1 or 2 lines of text. So millions and millions of people are using this kind of online websites for purchasing, many more. So the amount of data that is generated every second is huge in volume, for which we need analysis. So we must take extra care in analyzing such data to arrive at decisions. So wherein we are in a situation to develop a lot of enhanced tools for performing this data analysis to come out with the information which is very much helpful for timely and accurate decision making. So this timely and accurate decision making helps any business to run in a profitable way. Then visualization and mining. So whatever data we analyze, that data has to be represented in a way which is understood by the people in an easy way. And there we say visualization is helpful there. And mining, in earlier days we had database. See, we say the processing level of computers in 2 ways. That is, one is information processing, the other one is knowledge processing. Information processing is the one where information remains the same across people. Suppose when I say, which is the capital of Tamil Nadu, even if I pose this question to 1 lakh people, the answer of all those people would be Chennai, which is the capital of Tamil Nadu. Chennai will be the answer, even if I ask the questions to 1 lakh people. That is called information processing. And in the earlier days, we were using computers in the level of information processing. So we were using database tools like Oracle and other databases like FoxPro. In olden days, we were using FoxPro, DBase 3+, and database, SQL Server and all. So those database tools were used for information processing. A simple example I can say, if I give the subject marks, 3 subject marks of a student as 60, 70, 80, the total will be 210 always, 210. In whatever form I ask the question, the total of those 3 subject marks will be 210. It will not be varying across people, and that is called information. But knowledge is something different. So not only the marks, when I ask which student is best, the marks alone is not considered. Her overall performance, her attendance, how perfect she is to the classes. So we consider a lot of factors, and by analyzing that data, we say that student is good or better, like that. So this is what knowledge processing. And for knowledge processing, again, we depend on artificial intelligence. Then comes cyber security to improve the security measures to protect against cyber threats. See, today we are noticed by millions of eyes. We don't know that we are watched by others, but still many people are watching us, what we are doing, everything, our information, our bank details, everything is watched by many people, and there are a lot of chances for cyber crimes to occur, and we have a lot of threats also. So where we have to come out with solutions to prevent ourselves from these cyber crimes, and that is the cyber security. So these cyber threats come in the form of hacking, malware, ransomware. Maybe in future, if I talk to any person, he may from a remote place switch on the camera in my mobile, and he can say he can see what I am doing. So that is the question of privacy nowadays. So that is again a cyber threat. against which we people should go for doing a lot of research to protect all these, to protect the people from all these threats. And that is the cybersecurity. Then Internet of Things, again, Internet of Things is everywhere it is used, right from the agriculture farm to major multinational companies, we use Internet of Things. So it is used in smart homes. Like if I want to check whether the egg tray, suppose if the egg tray becomes empty, it will give me a signal to my mobile saying that your egg tray is empty, you go for buying some eggs. And if I leave the house and if I lock the door without people are there inside, so one of my internet things which is connected to the internet will say no one is there. And by remote access, I can put off all the lights, I can put off all the fans, or if AC machine is on, everything can be put down with the concept of smart homes. And that is possible with the concept of Internet of Things. And smart cities. So in big cities, dustbins are there. So if it is full and if it is under the surveillance of some cameras or some kind of sensors to sense whether these dustbins are full, immediately information will be given to the concerned person and they'll come and clean. So similarly, at night 6 o'clock they'll put on the lights, and by morning 6 o'clock the lights will be put off. So these will be automated. There is no need of human intervention. And there comes the role of Internet of Things, which are connected by internet. Again, the underlying concept is artificial intelligence. Then quantum computing. So the emerging trend nowadays is the quantum computing, because the volume of data what we process is huge. Then the algorithms and the mathematical models what we are going to use, they are very complex. To make a balance, we need improvisation in terms of hardware also. And there comes the concept of quantum computing, where massive parallelism is possible. So in a millisecond of time, millions of computations can be done with the help of quantum computing. And we need very speed processors. So out of this quantum computing, that is possible. Then human-computer interaction to design and evaluate interfaces that enhances user experience, accessibility, and usability. So we can speak with the remote missions with the help of interfaces. So wherein the chatbots, ChatGPT, you must be knowing the concepts of ChatGPTs and all. That is a technology that can be integrated. And we can communicate with the machines as if we are talking to the people. So that is human-computer interaction, with which everything is possible, and we are witnessing every day. What are the advancements that are coming in what is that information in the field of information technology? And as you know, networking and distributed systems. So to improve network performance, reliability, and security, then cloud computing. So we have our resources in a remote place, but by sitting in any corner of the world, we can have access to all those resources to have optimal utilization of those resources. So this networking and distributed system. So these concepts come under this head, where a lot of research opportunities are waiting for us. How to balance as far as the cloud computing is concerned, load balancing. We have to depend on multiple processes available in remote places, and people can submit their work to be executed in a different place. So these jobs will be taken to remote servers, and allotment of these jobs to available servers, it's again a challenge. So there we use artificial intelligence is used, identifying where and all the processes are available and how the submitted jobs can be efficiently allotted to all those processes. So as far as IT is concerned, these are all the major areas where we research opportunities are waiting for us. Next screen. Sir? Okay. So importance of AI. Today, AI plays an important role everywhere. So various fields we have seen now, no? Like distributed systems, robotics, computer vision. So in all the fields, AI find its place, and that too, it is in the top. So it has become an integral part of today's world, transforming numerous aspects of our life. And it is penetrating into the life of every individual. In future, even this AI can be embedded as part of our mobile phone, even our TV remotes. No, always we do this mistake. No, somewhere we will place our remote and we'll be searching for it. So in later it may happen. We can ask, okay, remember remote where you are. So it may give a reply saying that I'm here. You can come and take this. This is going to be the scenario that's going to be happening in the near future with the concept of artificial intelligence. So the two main advantages of artificial intelligence, that is automation and optimization. So automation, it streamlines the manufacturing process right from purchasing of raw materials, then manufacturing the items, the parts of a major product, and assembling them into a complete product. Then if there is a repeated tasks to be done in order to complete the manufacturing there and all, we replace the human beings with robots, and ultimately it ends up with the highest productivity. So we will be we will be able to manufacture products in lakhs. When it is done manually, it will be in less number, whereas if we automate using the concept of AI, the productivity will be more, and robots are involved in this kind of process where less time will be taken. And optimization, so AI optimizes business processes, supply chain business processes, just now I was explaining, and supply chains. See, supply chain is the concept used everywhere. So you take a huge hospital, right from the time of patient who is coming in, he is getting registered, and if he is admitted and if he undergoes any surgery, in every point a lot of data is generated, and this supply chain concept keeps track of the data right from the first point to the end point, and that will be analyzed. Finally it gives appropriate reports, and that is the supply chain. So this is in the hospital management, rightly from manufacturing also. We have to purchase, an order will be placed, then we have to procure the items from the vendors, and that has to be stored in the warehouse, and from warehouse the products are taken to the manufacturing point, the products are manufactured, then it is taken to the warehouse again, the finished products, from there it has to be sold. So these are all various points where data is generated, and all these data are to be collected and analyzed. So this is again a supply chain concept. And resource allocation, so in our, when we were studying, we had a paper, operations research, which takes care of the resource management, four M's that affect any business, no? Men, money, mission, material. So in order to have optimal utilization of all those resources, we were studying operations research. But there the data was less. But nowadays, we do business all over the world where the amount of data that is generated is more. So the information system, what we were using, now they have become useless because the volume of data is more, and data comes from various directions throughout the world. So now we have to go for artificial intelligence kind of tools to perfectly manage the data and analyze the data. So that is optimization. Next slide. Next slide, sir. So data analysis. So information is the key to any corporate success. If there is no data, no business can survive. And that is the scenario now. So we are living in the world of data. We are pooled with large amount of data. cluster. So this is called a clustering technique where we use unsupervised learning. If we don't have label, that is, we have the data set but without label. So if we get unpredicted in the unpredicted data, if we have unpredicted data, the system will be analyzing that data and grouping the similar data into clusters. So key characteristics: no labeled data, no predefined output, and focus on delivery. Only after getting the data we will be able to know what kind of data it is. Then types of unsupervised learning: we have clustering, dimensionality reduction. So what is dimensionality reduction? See, to start with, if we look at the feature set of any object, maybe it is a human being or an animal or a product, whatever it may be. So we start with a lot of features. See, let us take the example of census. When we collect details about all the human beings, we get their name, date of birth, address, parents' name, etc., 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 income, and all. But all these fields will not be necessary for doing the research. Just we want to know how many people are below poverty line. So this kind of category, this is how we have to categorize the data. So wherein their parent details are not needed, their address details are not needed. So initially we will be starting with maybe 30 or 40 features, but all these features are not necessary for doing the research. So the optimal set of features will be less than number 4 or 5. So that is called dimensionality reduction. Then comes anomaly detection. So you might have studied in data mining outlier. So one particular person, he is totally different from that group. That is called outlier. By using unsupervised learning techniques, we can easily identify odd man out from the similar data group. Then association rule mining. So in business, we all have studied in data mining. So if you sell this kind of product, what will be the other product? Always people tend to buy along with it. So this is called association rule mining. So which is used in business, and some of the applications where unsupervised learning is useful: customer segmentation, clustering is there; image compression, we go for clustering, and fault detection. So all products are, they don't have problems. One product, if it is damaged, we can easily find out. Or a person is continuously, we continuously withdraw money from banks using ATM. If any one unusual withdrawal is happening, immediately the system will be able to identify, because this is unusual from the other withdrawals. And recommendation system we have already seen. Next. So these are all the places where unsupervised learning techniques are used. Next, reinforcement. So here in reinforcement, we use neural networks, convolutional neural networks. In business, we use this kind of techniques where, say for example, where it is used. Say for example, a teacher is taking class for students. The next day, he keeps a test. The students will not perform up to the expectation of the teacher. The teacher may expect 100 marks, but the students will be scoring only 60. So the error value here is 60. The difference between 100 and 60, 40. The error rate is 40. But 40 is a huge difference, a big value. Then again, the student will be trained in a different ways. The next day, if the student writes the test, maybe 60 will be increased to 80, but still there is huge error, that is 20. The expected value is 100, but the score is only 80. The teacher expects more. Again, the students will be given many options to learn it in a better way. At any point of time, the student will be scoring 99 by repeatedly learning the particular thing. So the error value there, suppose if she gets 95, the training will be stopped, because 95 is acceptable. My expectation is 100, but the student can maximum score only 95, where the error is less value, where it is acceptable. And this is the way reinforcement learning technique is used. We repeatedly train the model till we get the expected output. So this is called reinforcement learning. It is used in many applications, game playing, robotics. See, a person who is playing chess, the day one, if he learns chess, definitely he will not be performing better. But if he repeatedly plays chess out of good experience, after a few days, he will be playing extraordinarily. So that is one example of our game playing, robotics, recommendation systems again, autonomous vehicles, self-driving cars. So these are all the applications where reinforcement learning techniques are used. And in reinforcement technique, many components are there. Again, there is a spelling mistake, sorry. The components of reinforcement learning: agent, the decision maker that takes action in the environment. The model, what we are going to design, is the agent. So this will take a decision whether the model is working better or not, whether the expected result is achieved or not. If it is not so, again, it will be completely trained. Then environment, where we are going to use it. Who is going to use this system? The external world that responds to the agent's action. The actions, the decision made by the agent, the model design. Suppose a self-driving car is moving straight, and if it detects any object that is coming in front of it, a decision will be taken, that is to stop or to move in the right side. So that is what actions. And rewards, the feedback received by the agent. As I told you, the expected mark is 100, but after writing the test immediately, after 2 days, the score will be only less, no, maybe 80. So the feedback, the given result will be given as 80. The feedback what we get is 80. Then again, we will try the system to meet the expected value. So that is what the feedback received by the agent. If the feedback is not acceptable, then we have to train the system. Policy, strategy used by the agent to select action. So what kind of training? How the training must be improvised? How to improvise the complexity of the model so that the expected results can be achieved. So these are all the various components involved in reinforcement learning techniques in order to make the system effective. Next. So we have seen the dominance of AI in the present scenario and the various techniques that come under AI, which are used for automating various fields in healthcare, business, etc. and etc. But whenever, as a researcher, if we come out with any system, we should give importance to ethical aspects. That we have to design a model in such a way that there should not be any bias. That is, while training the machine, see, you have to train the machine with proper proportion, the patients with cancer and the patients without cancer. There should be a balance in between the data. Suppose if we train the system with one set of data and losing another set of data, the result what we get out of those systems definitely will not be a reliable one. That is what bias. The data should be, we should feed the systems with proper data, which should contain both. Suppose if we use the system for classification and all, it should hold the data for both the groups. So that is how we have to feed the system with data. And job displacement. Job displacement, if we keep on incorporating, embedding AI with all techniques, so one day the entire world is, the AI powered systems will take control over the entire world, where human intervention will not be necessary at all. So we have to take into account those aspects, and accordingly we have to design the machines. And privacy, that's what I say. If we just keep on talking, if we use the mobile for if we attend a call, some person without our knowledge, he may make our camera active, and that camera will observe us, and those images will be taken to them. It may happen in the future. So privacy is again a challenge. And security. So definitely there are a lot of cyber threats booming up, and we must be very careful in designing AI powered systems to provide security, to prevent, to give privacy to the people, and job displacement. So people should also be given equal chance of working. Labels and all completely will be replaced by the robots in future. So we have to take much care in designing such systems. And technical challenges, data quality. So if the data is of good quality, the outputs that would be given by the AI systems will be of good quality. Otherwise, definitely false results will be obtained. And explainability. See, if we have chatbot kind of things and all, no, if we ask a question, the system, see, even if we use supervised learning techniques in classification, the system will classify, okay, this is a dog, or this person is affected with cancer, if it gives this kind of result. And if the user is asking, how come you are saying this person is affected with cancer? If we ask this kind of question, the system must be able to say, because of this reason, I am saying this person is affected with cancer. So this authentication must be given by the AI powered systems. That is what explainability. So what they are trying to insist is, if we are doing research, if we are going to design such systems, our system should be able to explain, give reasons for the results it is giving. That is what explainability and transparency. Explainability and transparency both are interchangeable. And social implications, digital divide. Obviously, in countries like India, there are affordable people, and there are set of people who are striving for their food even. But if we are going to have AI powered systems everywhere, definitely all people cannot enjoy the benefits. So the researchers, so you have that intention in designing systems where it should be usable by all kinds of people, whether they are affordable or if they are not affordable, both kind of people must be able to use the systems we are going to design. So we should put utmost care in not having digital divide. Inequality, yes, digital divide, inequality, they say the same thing. And dependence on technology. Suppose if we keep on developing AI powered systems everywhere, one day, if there is any problem with the technology, everyone will become handicapped. So these are all the major challenges in coming out with AI powered systems. So while doing research, or if you are going to design such systems, we should put utmost care to avoid these kind of things, and we should give importance also to overcome these challenges. Next. And future of AI, emerging trends, edge AI. Edge AI is nothing but whatever items we are using, the pen, the glass, the remote control, the mobile, everything is going to be powered by AI systems. That is what edge AI. And that is how the scenario is going to be. That's what initially I was saying, no? Always we forget things, no? If we embed AI powered systems as part of those things, we can easily identify them. Just we can call where AI remote control, where are you? Maybe the remote control will reply to us, I'm here, you can take me from this place. So this is how this edge AI is going to pervade into the life of every individual in their normal life. Then quantum AI, massive parallelism. This is in terms of hardware. So fast speed calculations, because the volume of data what we are going to process is huge. And to process this data, we need more time. It will take more time. But with the invent of quantum AI, the processing time will be minimized to a greater extent. And we need this kind of hardware technology to deal with AI systems, which requires more data to be analyzed. And transfer learning, we have to design AI systems in such a way that if we have already designed a system for one particular domain, by making small changes, that same system, it must be slightly modified and we can use it in another domain also. So we have to design systems in that way. That is what transfer learning. So the system that is designed for one domain can be modified and used in another domain also. This is what transfer learning. And autonomous systems, self-driving cars, these are all examples for autonomous systems. And in foreign countries, it is into effect. Tesla, a company, they have come out with cars with self-driving feature. And future opportunities, AI for social good, weather forecasting, AI-powered scientific discovery, even the scientific research will be enhanced with the help of AI-driven systems. And we should all work together to ensure AI benefits the society. AI it's a powerful tool, but it is in our hands to use it in a positive way. So that is what the message given if we go for designing systems with AI. And just move on to the next slide, sir, please. And the research phases, so everyone must be aware of problem definition. So suppose you're going to, the problem is, I'm just going to identify the disease, leaf disease, plant disease, so that it improvises the production. Identifying the disease and taking preventive measures will improvise the production, where we should go for implementing the IoT. So this is the problem. Identify a research problem or question in computer science. That is the first thing we have to do it. Whatever domain, what is the domain there? What is the problem existing? What is the existing problem there? How to rectify it? What kind of methodology is to be adopted? What kind of software applications to be developed? So this is what the problem definition. And literature. Suppose I'm going to install IoT for identifying the leaf disease. Then the literature review. So there may be some similar work already done by many researchers. We just go through all the works done already and identify the research gap. What is the limitation in the latest paper? So maybe papers from 2020, 21, 22, 23, 24. But even in a research work that has been published in 24, there may be some research gap. You identify that, for which literature review is very useful. Then research design, you develop a research design, including the research approach, methods, how we are going to implement it, how to acquire the data, what kind of hardware to be set up, how the data would be, if the data will be of good quality or something is missing there in the data or there is a noise, how to remove that, how to make the data ready to be processed. So these kind of things are done in research design right from the beginning to the end. Then data collection, actual collection of data, maybe through experiments, simulations or surveys or other methods. Then we go for data analysis, analyze the collected data using statistical methods, machine learning algorithms, or other techniques. We just saw dimensionality reduction. So optimizing the data set. If the data is of noise, then we have to remove the data, pre-process the data, transform the data from one form to another form. Say, for example, if we have rated the employees as, if we have given grades A, B, C, D like that for the employees. But if we want to do some calculations, alphabets cannot be manipulated. So you just transform A grade into maybe 10, B grade into maybe 7. Then the data will be made suitable for computations. So these are all done as part of data analysis. And statistical methods are there. So depending on the application, depending on the field, we have to identify appropriate statistical methods to analyze the data. And finally, results are generated. You interpret the results, drawing conclusions. So finally, we say whether the patient is having disease or not, and making recommendations, or if somebody else is asking which movie is popular now, then again, problem definition. We have to develop a recommendation system. The problem is developing a recommendation system. Literature review, already whether they have done research on recommendation system, what they have done, is there any scope for doing further research in developing recommendation system? Sorry. And the other things as we do with the software development. Finally, we have to validate the results. The results generated by the system, how far it is accurate how far it is better. So that's what validating. You have to validate the results and give the justification whether your system performs well when compared to that of others. Next. And different kinds of research methods, experimental, survey, case study research, simulation research, theoretical research. So it depends on the domain where we have to select the different kind of research. Next. So what I have explained already, it's given in the subsequent slides. Sorry, network issues from my side.
No problem, ma'am.
Hope we have come to the end. So if we can again go for presentation, maybe we can cover the remaining slides, maybe one or two. So with that, we shall wind up. So ethics, research ethics. So research ethics, we should not copy from others, and we have to do it in a genuine way. That is what research ethics. Maintain data confidentiality. Suppose we get data from any agents that should not be disclosed to others. So we have a lot of ethical constraints when doing research. Avoid bias in data collection. The data must be in a generalized form. So one-sided data should not be there. If we train the systems with a particular set of data, the results what we obtain from such systems again will not be a good one. And respect intellectual property, including patents, copyrights. After doing your research, you just try to go for publishing the patents, commercialize your products, let it be useful for the society. Next. That's all. So if you have any questions, please, or shall we wind up?
Thank you, ma'am, for an insightful session. Participants, we now open the floor for questions. Please feel free to ask your queries through the chat or raise your virtual hand to engage directly with our speaker.
Thank you.
Bindu, ma'am, you want to say something?
Yes, sir.
Yes, Bindu.
Good evening, everyone. On behalf of our organizing team, I extend our heartfelt gratitude to Dr. Vimla Ma'am, Head of Department, Mother Teresa University, Kodaikanal, for her invaluable contribution as a resource person in this faculty development program. Her vast experience spanning over 2 decades, distinguished academic and research achievements, and commitment to empowering educators have enriched this program immensely. Her insights into artificial intelligence, along with machine learning concepts, have provided valuable knowledge and inspiration to all participants. We sincerely thank her for her dedication and expertise in fostering academic excellence. I'm also proud to be a scholar. Thank you, ma'am.
Thank you, Bindu, for a wonderful Thanksgiving session. No? And I thank all the participants for patiently listening to my talk. Hope I have given some useful information to some extent. And shall we wind up the session now, Bindu?
Yes, ma'am.
Yeah, thank you.
Sure,
Thank
ma'am.
you so
Thank you.
much for
Thank you,
giving
ma'am.
the opportunity.
Thank you so much, ma'am. This is
Yes.
Shakti. Thank
Yeah,
you, ma'am.
thank you, Shakti. Thank you.
Thank you, ma'am. Thank you. Take care, ma'am.
Yeah, thank you so much.
Thank you, ma'am. Okay.
Yeah.
Dear participants, I have posted the attendance link in the chat box. Please fill it as soon as possible. Those who have filled the attendance link can leave the meeting now.